In 1977, humanity cast two small emissaries into the cosmic void, probes destined to roam the outer reaches of our solar system and beyond. Launched in an era when the stars still felt impossibly distant, these spacecraft carried the hopes of a species eager to touch the unknown. Nearly 5 decades later, they have unveiled a phenomenon that defies expectation: a searing, turbulent boundary at the edge of the sun's domain, a region of superheated plasma glowing at temperatures between 54,000 and 90,000 degrees Fahrenheit. This is no ordinary frontier. It is a dynamic, enigmatic interface where the sun's influence wanes and the galaxy's vastness asserts itself. This mysterious wall of fire at the heliopause, detected by both probes years apart, challenges everything we thought we knew about the solar system's limits and its connection to the interstellar expanse. The discovery reshapes our understanding of where we stand in the cosmos, revealing a boundary not as a passive line, but as a vibrant, contested zone where solar and galactic forces collide. Let us journey to this edge to explore what was found, why it matters, and what it means for humanity's place in the universe. The heliopause marks the threshold where the solar wind, a ceaseless stream of charged particles from the sun, finally yields to the interstellar medium, the sparse sea of particles and magnetic fields that fills the space between stars. For decades, scientists envisioned this boundary as a tidy transition, a place where the sun's dominance gently faded into the galaxy's embrace. But when the first probe crossed this frontier in 2012, followed by its twin in 2018, they revealed something far more complex. Instead of a smooth handover, the probes encountered a narrow, searing zone of plasma, its particles vibrating with such ferocious energy that they registered temperatures equivalent to tens of thousands of degrees. This is not a wall in any tangible sense, not a structure of flame or matter as we know it. The particle density here is so low, far thinner than the best vacuums crafted on Earth, that heat does not conduct or radiate as it does in our atmosphere. Yet the particles themselves, sparse as they are, carry immense energy, their frenetic motion painting a picture of a boundary alive with cosmic forces. This region, scientists propose, owes its intensity to the collision of the solar wind with interstellar particles, compressing the plasma and igniting it with heat. Magnetic reconnection, where the sun's magnetic field lines tangle and snap with those of the galaxy, adds bursts of energy, further fueling this turbulent zone. What stunned researchers was not just the discovery, but its consistency. The second probe, crossing years later at a different point along the heliopause, found the same searing conditions, confirming this wall of fire as a persistent, defining feature of our solar system's edge. This was no isolated quirk. The twin detections, separated by time and space, point to a fundamental truth about the heliopause. It is not a static barrier, but a dynamic crucible, where the sun and the galaxy wage a ceaseless tug-of-war. The intense plasma heating suggests processes far more intricate than previously imagined. Magnetic reconnection likely plays a starring role as solar and interstellar magnetic fields collide, merge, and release torrents of energy. These events accelerate particles to staggering speeds, creating the extreme temperatures the probes recorded. But the discoveries go deeper. Beyond the heliopause, the interstellar magnetic field aligns unexpectedly with the sun's own field within the heliosphere. This alignment defies earlier models, which assumed the galaxy's magnetic structure would differ sharply from our stars. Instead, the data hint at a profound connection, as if the sun's influence subtly sculpts the interstellar medium, or perhaps the galaxy imposes its own order on the solar system's edge. This alignment has far-reaching implications. Cosmic rays, high-energy particles born in the violent hearts of distant stars or black holes, must navigate this boundary to reach the inner solar system. The heliosphere acts as a shield, deflecting many of these rays. If the heliopause is more turbulent and permeable than once thought, it could allow more cosmic radiation to slip through, potentially affecting the planets, including Earth. This discovery forces us to rethink not just the heliopause, but the very shape and behavior of the heliosphere itself, the protective bubble carved by the sun's winds. The implications of this finding ripple across science, challenging long-held assumptions and opening new frontiers of inquiry. The heliopause, once seen as a passive divide, emerges as a vibrant interface, a place of constant transformation, where the sun's reach grapples with the galaxy's vastness. The intense plasma heating points to large-scale magnetic reconnection, a process that could reshape our models of heliospheric physics. If the sun's magnetic field extends its influence farther than expected, it suggests our star plays a larger role in shaping its galactic neighborhood. Alternatively, the interstellar medium may exert its own organizing force, aligning magnetic fields in ways that ripple across vast distances. This interplay could affect how cosmic rays penetrate the heliosphere, altering the radiation environment of the inner solar system. For Earth, this matters. Cosmic rays influence atmospheric chemistry, cloud formation, and even climate over cosmic timescales. A more permeable heliopause could mean a solar system more exposed to the galaxy's whims, with consequences we are only beginning to grasp. Beyond our star, these findings offer a window into the lives of other stellar systems. Every star carves its own heliosphere, a bubble shielding its planets from the interstellar medium. If our heliopause is this dynamic, others likely are too, suggesting a universe where stellar boundaries are not walls but active evolving frontiers. This discovery redefines the solar system not as an isolated fortress, but as a participant in a larger galactic dance, its edges shaped by forces far beyond its control. The data from these probes also reveal the heliopause as a place of unexpected beauty and violence. The wall of fire is not a literal blaze, but a symphony of particle collisions and magnetic storms. A region where the sun's waning breath meets the galaxy's ancient currents. This turbulence challenges engineers and scientists planning future missions beyond the heliosphere. The extreme conditions, plasma hotter than the sun's surface, magnetic fields twisting and snapping, demand spacecraft built to withstand forces we are only now beginning to understand. Shielding must account for energetic particles, instrumentation must endure magnetic turbulence, and communication systems must pierce the interference of this chaotic zone. The upcoming interstellar mapping and acceleration probe, set to launch in the near future, will build on these discoveries. Its advanced sensors will map the solar wind's interaction with the interstellar medium, offering a clearer picture of the heliopause's physics. By studying the flow of particles and fields, it will help unravel the mysteries of this fiery boundary, providing context for the probe's findings and refining our models of the heliosphere's shape and behavior. These insights will guide the design of future interstellar missions, ensuring they can navigate the turbulent frontier where our star's influence fades. This discovery also carries a philosophical weight, forcing us to confront our place in the cosmos. The heliopause is not just a scientific boundary, it is a threshold between the familiar and the infinite. For centuries, humanity has gazed at the stars, imagining them as distant beacons in a vast, unknowable void. Now we have touched the edge of our solar system and found it alive with energy, a place where the sun's reach meets the galaxy's embrace. This wall of fire is a reminder that the universe is not a static backdrop, but a dynamic, interconnected web of forces. The alignment of magnetic fields suggests a unity between our star and the galaxy, a connection that binds us to the larger cosmos in ways we are only beginning to comprehend. What does it mean to live within a heliosphere that is not a fortress, but a porous, evolving boundary? How does our understanding of the solar system change when we see it as a participant in a galactic ecosystem, shaped by forces far beyond its borders? These questions challenge not just our science, but our sense of identity, urging us to see ourselves as citizens of a universe far grander and more complex than we ever imagined. The enduring legacy of these probes lies in their ability to surprise us, to reveal truths we could not have anticipated when they were launched nearly half a century ago. Built in an era before smartphones or global networks, these spacecraft were designed to explore the outer planets and then drift into the unknown. Yet they continue to send back data, faint whispers from the edge of the solar system, each transmission a testament to human ingenuity and curiosity. As their power dwindles, engineers have begun shutting down instruments to stretch their lifespans. Yet key systems are expected to function for at least another year, perhaps longer. Each byte of data they return is a gift, a glimpse into a region no other human-made object has ever reached. Their discovery of the Wall of Fire raises new questions that will outlive their mission. How far does the sun's influence truly extend? What other forces shape the heliopause? And how do they affect the solar system's place in the galaxy? These are not just scientific inquiries, but existential ones, probing the boundaries of our knowledge and our place in the cosmic order. The heliopause, with its searing plasma and tangled magnetic fields, is a frontier unlike any other. It is not a wall to be crossed, but a region to be understood, a place where the sun's story meets the galaxy's narrative. The Wall of Fire is a metaphor for this collision, a boundary that burns with energy, not flame, and speaks to the universe's ceaseless creativity. As we ponder this discovery, we are reminded that exploration is not just about reaching new places, but about seeing the familiar in a new light. The solar system, once thought to end in a quiet fade, now appears as a vibrant, contested edge, alive with the interplay of cosmic forces. Future missions will build on this knowledge, probing deeper into the heliopause and beyond, seeking answers to questions we are only now learning to ask. What lies in the interstellar void? How does our star's influence shape the galaxy? And how does the galaxy, in turn, shape us? These are the mysteries that beckon, calling us to look beyond the heliopause, to the stars and the secrets they hold. The journey of these probes is a testament to humanity's unrelenting drive to explore, to push past the known and confront the unknown. Nearly 5 decades after their launch, they have revealed a boundary that is not an end, but a beginning. A fiery, turbulent threshold where the sun's domain meets the galaxy's vastness. The Wall of Fire is a beacon, illuminating the complexity of our cosmic neighborhood and challenging us to rethink our place within it. As we stand on the cusp of new missions and new discoveries, the heliopause reminds us that the universe is not a distant abstraction, but a living, dynamic reality, one we are only beginning to understand. The frontier is not a line to be crossed, but a story to be told, and we are only at the opening chapter. Stay tuned, for the cosmos is calling, and its secrets are waiting to be unveiled.